we are going to discuss some two-dimensional problems. Collision in two dimensions, those ideas we are going to implement here. So as usual, like if you can recollect, if this is the mass of incident particle, it is incident with some kinetic energy, let it be Ki. And there's a target nucleus. There's a target nucleus. So reaction will occur. Then what is the minimum kinetic energy this particular incident particle should come so that the reaction will occur? So let it be Mi. Already we have discussed, so they'll move with a common velocity of center of mass. Then if you go for this minimum kinetic energy for the reaction to occur, they should be equal to 1 plus Mi plus Mt. Now, can you remember this Q? What happened? It was delta E. What is Q? Q is equal to, you can write it as Mi mass of parent minus mass of, or just time being, let me write here. Q is what? Delta M into C square. So in a reaction Q negative, then what happened? We have to supply that energy. And what is that minimum kinetic energy? What happened? The incident particle should possess so that the reaction will take place here. So I think there's a one formula. Can you remember this? This was a delta E, no? In atomic physics. Please do recollect. This was delta E. This quantity was delta E. So what is that minimum kinetic energy? We'll go for it. So in most of the nuclear reactions, what happens? Sometimes we have to initiate. We have to initiate that one. So what should be the energy possessed by that particle is what? We say like this here. Then in some reactions where the Q is positive, we'll call that as exothermic reactions. In this case, what actually happens? Mass of parent will be greater than mass of daughter. And when you calculate, it will be like this: Mp minus Md is equal into C square. Mass of parent minus mass of daughter. In some reactions, Q will become negative. We'll call that as endothermic reactions, where the mass of parent will be less than mass of daughter. So in that case, definitely when you take difference, so what do you get? You'll get negative. Then if you supply that much of energy needed for reaction to occur, it comes. So next, is it just if you supply Q, who will supply that? Some particle like a neutron, proton, or alpha particle. These are what usually we prefer. So what minimum kinetic energy that particular incident particle should possess? That formula is given by this one. And this is called as minimum. Some book they call threshold kinetic energy, KTH. If the next question comes, so what happens if the incident particle comes with kinetic energy more than this? If it comes with more than this, now what has to be done if it is more than this? If it is more than that, what will happen? They will not get stuck, no? I think if you can remember, there's the add-on collision we are discussing first. No? If the incident particle comes with kinetic energy more than this, means like if Ki is greater than K minimum, then what will happen to the particles? They need not to stuck. Perfect inelastic collision will not occur. If the incident particle comes with kinetic energy equal to K minimum, then perfect inelastic collision. If it comes with greater than K minimum, it will be add-on or two-dimensional collision. I think I'll go for some very generalization. This is X. There's a target Y. And after this, we'll write one general conclusion, we'll make it. Suppose there's a reaction, X plus Y will become W plus Z. No, sir, if Q is negative for this, first case we'll discuss. There's a reaction. Huh? If Q is positive, what to do now? Q is negative. What to do? Then the particle X, there's a target nucleus. Y is a target nucleus. X is incident particle. After reaction, what happen? This X and Y will become parent, W and Z will become daughter. No longer after reaction, like beta decay, alpha decay, uranium, what happened? No longer the daughter will be not that of parent. So therefore, I'm writing some W and Z. So this will become daughter. These will become parents. Then what should be the minimum kinetic energy possessed by the incident particle to initiate this reaction? In that case, what we write here is Ky. So this should be equal to minimum kinetic energy possessed by the incident particle. In this case, should be equal to mod of Q 1 plus mx by my. Will I agree? How to calculate Q? Again, the method is same. Mx plus my. I'm first generalizing it so that numericals will be very easy for you to analyze. Because straight away, if I jump numerical, no, you'll get a lot of trouble. So I'm very sure is what Q is negative, because I'm very sure mx plus my is less than. So therefore, we have to supply the energy. What minimum energy? This one. Next year, uh, what will happen if you supply energy more than this? Because this was the usually question. It can happen in a reaction. I may supply energy more than this. In that case, the W and Z, what happened, need not to get stuck. Means what is this? When it comes with minimum kinetic energy, I'll write down the one possible, this one. Kx is moving, and this is the nucleus, target nucleus, which is at rest. After collision, no longer they'll become xy, they'll become some other W and Z, and they'll move with a common velocity. Fine. So this is what perfect inelastic collision. This is the first case. And second case, Q negative, but the kinetic energy of the particle X is greater than Kx minimum or threshold. That in that case, what will happen? Kx, it is incident on the nucleus which is at rest. After collision, what will happen is the W and this will move with one kinetic energy. This will move with one kinetic energy. They need not to get stuck. No, it can also happen. Oh, already reached page end. Just a small that methodology, nothing else is there. Afterwards, you can manage any numerical. No, third situation. This was add-on. Both these are add-on collisions. So now it can also happen when kx greater than minimum. And some book they called a threshold, because in atomic physics what we called minimum. Here in the books what they called it as threshold. So now in this case, so here they get stuck. Here not, no, they are separate, no. You can see from here. They're moving with the different kinetic energies. Okay, now this is nucleus at rest. What can happen? There's another possibility. The collision may not be one dimension, may not be add-on. The collision may not be add-on. It can also happen. So may not be add-on means after collision, the X will be moving like this and the Y will be W will be moving like this, Z will be moving. Let me put in order, systematic order. Can you remember we have done some similar problems in atomic physics? It can happen like this. And it'll get deflected. It can happen. So what is your entire question? If Q is negative, how to say Q negative? I think the masses will be given, mass of the parent and that one. And look at the incident particle. What is the minimum kinetic energy for it? It must possess to initiate the reaction. If it just comes with minimum kinetic energy, no problem. If it comes with energy more than minimum, no, then which will happen? Second or third, we don't know. You have to mention in the question has to be given. Are you getting no? Nobody can predict. Even nobody can predict here. What happens is what you have to make observation. Practically, what that occurs, what happen from that they'll analyze here. But we can never ensure that this will only happen. We can never ensure that this will only happen. Are you sure that one? So it's a add-on or it's a two-dimensional. They will mention. So these are the three situations what you come across. Now, sir, what happens if the incident particle comes with kinetic energy less than minimum? It's quite clear. It can be elastic or it can be inelastic, but reaction will not occur. I think it's of no use of discussion, no? Because in the especially the nuclear reactions, lot of like a amount will be invested. If the reaction fails, what will happen? Then money will be wasted, no? So that's why in the books they never bothered anything about if the kinetic energy of incident particle less than K minimum kinetic energy to initiate reaction. It's of no discussion of that. Even if they ask you what happened, it can be some add-on collision, but reaction will not occur. It not become WZ, they'll remain as XY only. If the if the kinetic energy of the particle, incident particle, if it's less than this K minimum, then no longer this reaction will not occur. They'll just, the parents will remain as parents. They don't produce any daughters. That's why the books, they didn't bother to discuss. So just be alert that condition also. If Q positive, what has to be done? Q positive. And that's, I think I need not to bother anything. No, the reaction will take place on its own. Then this is the incident particle. It is coming with some kinetic energy. This is a target nucleus. Most of the cases, target nucleus will be at rest. Again, sir, target nucleus also moving. It will be very complicated. The system will become very complicated. So usually the nuclear reaction, how it takes place with uranium at rest, because fuel rods, you see, no, almost what we have, the most of the nuclear reactions, 98% of reactions, the target nucleus will be at rest. This is the incident particle. Now tell me what can happen here. They will collide and the reaction occurs, X plus Y. These are daughters and these are parents. Okay, after collision, they will move with a, and this is Z. Yeah, that's all it can happen. But they don't get stuck, no. No, what is the equation we should write here? This is something very important. What is the equation we can write? Similarly, sir, can you write equation for this? We want some equation because, okay, diagram fine. Mathematically, we should solve, no? The equation will come like this, Kx plus Q. You are going to substitute Q with sign. Q negative, put sign that one. That should be equal to Kw plus Kz. Then apply conservation of linear momentum, two unknowns, two equations you can solve. Then conservation of equation. Books, they didn't explain because they didn't explain all this, assuming that you know collision concept. So don't blame book or don't blame any author. So that book didn't explain nothing. You know enough of collision, conservation of energy, you know, conservation of momentum concept, you know, finish. Or there's no need to separately discuss these things. Huh? Don't think negatively. Sir, the book nothing given. Now substitute Q with sign. I think that the best practice what you can put it. So here what all it should do, this incident particle, it should come with it should come with energy to initiate reaction, and also the daughters, the products must have kinetic energy, you know? So it should carry both the energies. What is this? If you substitute Q negative, what's happened? It'll come in RHS, no? It'll come in RHS. So some books what happen, they have given like this. This is same equation. Some books they given. I think nothing wrong. Now you may be able to understand a little bit clearly here. What is that? The incident particle should carry energy for the reaction to occur, and also the products will have kinetic energy. Sir, why you are bringing KWKZ? Just let it come with only kinetic energy. See, like you have to, what are products are very important. I should collect it, no? When do I can collect? If they are in, if they possess some momentum, use some common sense, because we are using this nuclear reaction what? To get not IT rank. Of course, we may study for that purpose, but practically what happen? Why do we use nuclear reactions? For some application. So definitely the products what happen? I should gather the products, no? I should gather products means that products must have some kinetic energy, then only I can gather. I can separate them. So that's why, so what all reactions occur, what happen? I should see that the products must have kinetic energy. That's what all the, everything is what we are analyzing here. If you are putting mod something, you should write like this, or substitute Q with sign in LHS. Both are same. I'm writing or. What is the reaction? The same thing. Kx plus Q equal to Kw plus Kz. What about here, sir? Momentum equation is, we can write it here. This should be equal to 2mz kz cos theta along x-axis, along y-axis w minus three equations, any three theta, kw, three equations they are known, we can solve it. This is what happened, Q with sign, strictly. So it is best practice that Q always put in LHS, substitute with sign. How to write equation for this? Kx plus Q equal to Kw plus Kz. So now look at this Q. Already the energy is sufficient from the reaction, and also you are supplying additional. So what happened? The energy available due to reaction plus the energy of incident particle together will be converted into kinetic energy of the fragments. So it's a best thing, like don't shift to RHS like what I did, because to make you understand concept. But in numerical solvent, just write in this way: Q negative, let it be here. If Q positive, let it be here. In LHS, substitute Q with sign. No, this is one possibility. In Q positive. No, one more possibility is the same thing. The incident particle Kx. After collision, maybe W go like this. I shown perpendicular, no? Let me show some other angle here. After this, they may deflect. Theta 1, theta 2, anything it can be. You can pick up that one. So here what is again equation? Kx plus Q equal to Kw plus Kz. Then apply conservation of linear momentum. So what is the formula? 2mx Kx is equal to 2mw Kw cos theta 1. This is along x-axis. Along y-axis, initial momentum is equal to solving these two equations to unknown. So we'll get the required answer. Okay, fine. I just generalized everything. Now you can pick up any problem. Let's not bother sir, parent, daughter, what they give. Let's take that one and work out here. So they'll give some atomic masses. From that, we'll get the Q. How to calculate Q? If they give binding energy, okay, take binding energy. If they give atomic masses, take atomic masses and calculate Q. The general conclusion is what? We are going to make it here. No.